Okay, so now we're going to look at solving identities. That means proving the left hand side equal to the right hand side. Very important. Again, you can see that I wrote the two sides separate. I did not make them equal to because it's not proven yet, and that's very important to remember. Because I'm using the Via Afrika textbook. I'm currently at chapter 6, exercise 3, and I'm going to do question 2, 4, 6, 8, and 10 as examples of proving identities. Okay, so you can clearly see here that we have a tan squared x on the left hand side, and I know that can be converted by using the quotient identity, and that's the very first thing I'm going to do. Let's do that. Cos squared x bracket sine squared x divided by cos squared x plus 2. Okay, so again we've got a bracket with a fraction in it, and it would be much easier to work with it if we have one fraction inside the bracket, so that we can have a common denominator or a common factor or something that can cancel out, which has to apply to everything inside the bracket. So that's the next step, to get a common denominator right over there. So it will be cos squared x bracket sine squared x plus 2 cos squared x, and all of that divided by cos squared x. Okay, now it's works towards our favor. You can cancel out the cos squared x because it's common to the whole bracket, and then it's important to have a look at your right hand side every now and then to make sure that you're on the right track. So we've got a sine squared x. There's the only unknown that we have. The rest is numbers. So over here we can convert the cos squared x and write it in terms of sine squared x by using the identity, the square identity. So we are going to use an identity right over there. And we know that identity will look as follows. 1 minus sine squared x. So that's the identity that we substituted in. Let's multiply the two into the bracket. And then simplify. Sine squared x minus 2 sine squared x is just a minus sine squared x, and that is equal to our right hand side. Okay, we're looking at number 4. You can see the left hand side is cos beta over tan beta plus sine beta. The right hand side 1 over sine beta. So the right hand side is more simple than the left hand side. It's a single term, it's a single unknown, it's a variable, so we're just going to leave the right hand side as is, so we know what we're working towards, but we're going to start with the left hand side. Okay, so the only identity that we can apply currently is our quotient identity, tan beta. So let's apply that one. So the left hand side becomes cos beta divided by sine beta over cos beta plus sine beta. Okay, now let's divide, and you will see that this becomes cos square beta over sine beta. If you multiply with the reciprocal of the denominator there, it will become this, and do not forget the sine beta, that's still there. Okay, again, we want to work towards a common denominator so that we can have a single term on the left hand side as well, because we know on the right hand side we've got a single term. So that's the next step. Common denominator, we can get that by multiplying the sine beta with sine beta over sine beta, and it will give us sine squared beta. And yes, then we see we have our square identity that we can apply there, and that makes the numerator equal to 1. The denominator is still sine beta, and that is equal to our right hand side. Let's do number 6 from exercise 3. So again, our right hand side is already a single term, simplified one variable, so we're just going to leave it as is. We're going to work with the left hand side. Okay, so it is clear at the end of the day we're going to have to get rid of the sine x, but don't be tempted now to cancel or anything like that, because it's not allowed. You can't do that, so please be careful of that. You will see I follow basic steps every time. In this case it would be no different. So first step is to work towards a common fraction, just one single fraction, because the right hand side is also equal to one fraction. So we're going to achieve that through the lowest common denominator. So it will become cos x times cos x minus sine x times 1 minus sine x, and then our common denominator is 1 minus sine x times cos x. Do not multiply the denominator. You only do that at the end if needed. So let's simplify the numerator. So cos x times cos x is cos squared x minus sine x plus sine squared x divided by 1 minus sine x in a bracket times cos x. If you look at those two, cos squared x plus sine squared x, that is an identity, a square identity. You can apply that now and see it will become 1 minus sine x divided by 1 minus sine x times cos x. We can cancel those two out, and it will be equal to 1 divided by cos x. That's equal to our right hand side. Okay, number 8. On the left hand side, cos to the power of 4x minus sine to the power of 4x over cos x plus sine x. Right hand side, cos x minus sine x. You immediately notice a difference between two squares, so we're going to use that to our advantage, and let's work with it. So it will become cos squared x minus sine squared x times cos squared x plus sine squared x. The denominator we leave as is. We cannot simplify that one. You will notice we have an identity over here that's equal to 1. So this will just become cos squared x minus sine squared x divided by cos x plus sin x. Okay, so now the numerator is yet again the difference between two squares. So this will become cos x minus sin x times cos x plus sin x divided by cos x plus sin x. These two cancel out and you will be left with cos x minus sin x equal to the right hand side. Okay, number 10, the last one for this video. The right hand side is equal to tan x. We can write this down as sin x over cos x just to help us see what we're working towards. Okay, so let's work with the left hand side. Left hand side, we've got a tan x over there, so I'm definitely going to change that by using the quotient identity into sin x over cos x minus sin x times cos x divided by sin squared x. Okay, your calculations are much easier if you have a common denominator or a single fraction. So that's what I'm going to do with this numerator before we can do anything else. So it will become sin x minus sin x cos x times cos x divided by cos x, all of it divided by sin squared x. Now this will become a cos squared x. So you can see we've got a common factor for these two terms. So I will start off by simplifying that. So this will become a sin x bracket 1 minus cos squared x divided by cos x divided by sin squared x. Okay, we see an identity right there in the bracket. So sin x times sin squared x divided by cos x. Now let's multiply with the reciprocal of the denominator, which is sin squared x. So it will become 1 over sin squared x. By doing that, these two cancel out and you are left with a single term sin x over cos x, that is equal to our right hand side.